we're going to do page 8, and we're going to start with here 9b. So if this binomial expansion with an unknown degree is equal to 1 minus 12x plus 60x squared minus blah, 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 find the values of k and n. Okay, so this is another one of those backwards problems where we don't know what n is. We know what a and b are, but we don't know what n is, and then they give us part of the expansion. So don't panic. So let's write down what the a and the b are. So a is 1. So a being 1, that's a little bit suspicious, right? That is a super easy a value. So like, notice they're compensating the fact that this is a difficult problem, an unfamiliar problem, by giving us an a value that's very easy, okay? All right, so how are we going to do this? We know that the first 3 terms are this. What do the first 3 terms look like from the general term formula point of view? So it would be, this is our general term formula. N chooses R, a to the n minus r, b to the r. Okay, that's what it looks like in the formula booklet. Our n value is unknown. The r value for the first term is 0, right? And of course, the a value is 1, so we could put 1 to the n minus r, but 1 to the n minus r is just 1, so we won't even write the a value, okay? It would, if we wrote it, it would be 1 to the, unknown n minus 0, but this is just 1, so we're not even going to write it. Okay. Let's look at the b value. So the b value is kx. So we're going to put kx in parentheses, and then we're going to put it to the r power. Except we know r in this case. Since this is the very first term, the r value is 0, right? The r value here is 0, the r value here is 1, the r value here is 2, okay? Because the first term is r equals 0, the second term r equals 1, etc. So this would be r equals 0. Oh, so that's 1 also. So basically, our first term is going to be n chooses 0, and n chooses 0, remember Pascal's triangle, the first number in the row is always 1, 2. So this is just 1 also. So the whole thing is just 1, so we don't need to do the general term for the first term. We know it's 1 already, okay? Now let's do the second one. So the second one would be n chooses 1, and then it would be the a. We don't need to put the a expression because it's 1, and then we just put the b, which is kx to the 1, right? And then finally, we're going to do the third term. And the third term is n chooses 2, and then the kx is to the second power. Okay, now let's expand this out a little bit. So n chooses 1, I'm going to write it the other way because it's a little bit more compact, times kx plus, and then here I'm going to put n chooses 2, and then I'm going to put k squared x squared. Now I'm going to match it up with what's up here. So the 1 matches with the 1. This matches with negative 12x. And then this matches with 60x squared. Okay, so from this, we could just, set equal the non-x part here. And we could set the non-x squared part here. And those two are equal to each other. We'll make a little algebra problem. By the way, what's n chooses 1? N chooses 1 is n, right? The second number in a Pascal triangle row is always just the degree, okay? So this, we could simplify this to nkx, okay? So we know that the second term is nkx, which means that the coefficient is nk, and this coefficient is negative 12. So we know that n times k is negative 12, okay? And then for the third term, n chooses 2. We don't know what n chooses 2 is, but we know that the coefficient is going to be the n chooses 2 coefficient times k squared, and that is equal to 60. Okay. Does that help a little bit? Not sure. Okay. So let's try to use these two together to solve something. So let's take n chooses 2, and then we'll use the equation for n chooses r. Remember, is equal to n factorial over r factorial times n minus r factorial. So we're going to put, instead of n chooses 2, we're going to put n factorial, and then we'll put 2 factorial, which is just 2, and then n minus 2 factorial. Okay, and and then we put k squared equals 60. Okay, and we could simplify this a little bit, right? Because if you have n factorial divided by n minus 2 factorial, isn't that just n times n minus 1 and nothing else? Right? N factorial divided by n minus 2 factorial is n times n minus 1. K squared equals 60. Okay, so we have n times n minus 1, k squared equals 120, right? Okay, now let's take let's try to get rid of our k value here. So our k value is also equal to negative 12 over n. So instead of k squared, we're going to put negative 12 over n, okay? So we'll put n times n minus 1, k squared, which is going to be negative 12 squared, which is 144, positive 144, divided by n squared equals 120, okay? So now we have n minus 1, and then so the n cancels with the n squared, and then we just have n here. And now we have n minus 1 divided by n equals 120 over 144. Okay, now we can just solve this with algebra, right? We can multiply both sides by n. We could multiply both sides by 144. So that would be, do a cross multiply to get rid of the fractions here. Okay, 144n minus 144 equals 120n. And then I'm going to subtract 120n from both sides, so there'll be 24n minus 144 equals 0. And then add 144 both sides, that'll be 24n equals 144. And then and I divide both sides by 24. 144 divided by 24 is equal to 6. Okay, if you did that in the calculator, you'd see it was 6. And there is my n value. We figured that out. Now to figure out the k value, we just say k equals negative 12 over positive 6, right? Because negative 12 divided by n. So that would be k equals negative 2. So these are the two values. Now, you might say, how the heck am I ever supposed to solve this problem? Well, this is probably, if this was on the exam, one of the problems that they're used to figure out who gets a 7, right? So you don't have to get all the points on this. What you want to do is get most of the points. So how do you get most of the points? Well, you're going to write down the general term formula. You're going to start expanding it out as much as you can. You're going to substitute in the a value, the b value. You're going to try to substitute in simpler values for n chooses 1 and n chooses 2. And then the rest of it's just algebra, right? So, but if you get this pretty much this far, then you've gotten, probably more than half the points, okay? So that is one of the most difficult problems in the problem set, and there are problems like this on the exam occasionally. So if you get that, then that would be a problem to see who gets a 7. Okay, so for the rest of page 8, in this video, we are going to look at the algebra method to solve number 10 here. So let's see, first thing we're going to do is we're going to write down the formula for the general term, which is n chooses r, a to the n minus r, b to the r. On the formula booklet, it looks like something like this. But same thing, right? Okay. What is a and b? So a is equal to x squared. b is equal to 1 over ax. And n is equal to 10. Okay. So basically what we're going to do is we're going to put these values into the general term. And then we're going to set it equal to the x to the 11th term, which we already know the coefficient is 15. So eventually this is going to be equal to 15x to the 11th. And we're just going to figure out what the r value would be and what the b value would be. exactly, because there's an a here, to make this 15x to the 11th. Don't get confused that there's an a here and an a here. Okay, think of this as the red a and this is the black a, I guess. I don't know. Let's fill everything in. Okay, so n chooses r. That would be 10 chooses r. We don't know what r is yet. The a value is x squared. Let's put parentheses around everything. N minus r would be 10 minus r. The b value is 1 over ax. Okay, this is the black a. Sorry to confuse you by right. Let's make it a blue a. Okay, I'll just make it a blue a. Okay. And the b exponent is r. Okay, and so we know that this is equal to 15x to the 11th. All right. So what we're going to do first is we're going to try to figure out what the r value is by only looking at the variable part. So we're only going to look at this part. We're going to ignore the 15. We're going to ignore Pascal's triangle coefficient because that's just a number. We're going to ignore the a because that's just a number. Okay, so let's do that. X squared to the 10 minus r divided by x to the r, right? The top is just 1, equals x to the 11th. Okay, so let's simplify this left side so that it's just one exponent expression. So x to the 2 to the 10 minus r would be, we're going to multiply 2 times 10, that would be 20. We're going to multiply 2 times negative r, that would be minus 2r. And then we're going to change x to the r to a negative exponent to bring it to the numerator. And now we're going to combine these two exponents by adding, because there's two bases. So 20 minus 2r minus r equals x to the 11th. Now we can just look at the exponents because the bases are the same. So let's write one big algebra equation. 20 minus 2r minus r equals 11. That's equal to 20 minus 3r equals 11. And then let's subtract 11 from both sides. And we'll add 3r to both sides. And then we'll have 9 equals 3r. R equals, divide both sides by 3, r equals 3. So this is pretty much all we need. Let's fill that in. We know that r equals 3 now. So now we know that it's 10 chooses 3. And we know it's x squared to the 10 minus 3, which would be to the 7th. And then we know 1 over ax. Oh, that's the blue a. Okay, this is the blue a as opposed to the red a. To the r equals 3, okay? And now we know that's equal to 15x to the 11th. Okay, so we already worked out that this x here and this x here is going to divide out and become x to the 11th. Let's figure out how to get the 15 now. Okay, so now instead of looking at the x's, we're going to look at, the numeric part, which is just, these two pieces. Everything else is the variable we can ignore now. And we're going to look at the 15. How do we make that equal to 15? Okay, so now what we're going to do is we're going to say 10 chooses 3 times 1 over a cubed. Okay, so I'm just writing the yellow part, equals 15. And this is a pretty, it's not a difficult algebra equation. What's 10 chooses 3? 10 chooses 3, we'll do that with the calculator. Oh, 10 chooses 3, it's 120. I already did it. So 120, 1 cubed is just 1, a cubed in the denominator is a cubed equals 15. Let's multiply both sides by a cubed. 120 equals 15 a cubed. And then a cubed equals 120 divided by 15. A cubed equals 8. And a equals 2.